So, good morning again. I invite you to our webinar about automation. Uh, I think we start anyway, if not all are here. Our today's, uh, let's see. Uh, I share now my screen that you can follow my slides. 1 second. Um, so I hope everybody can hear me. And if not, please let me know. Okay, this looks great. So today we want to talk about automation, from automation to AI and robot vision. What is the idea of it? So as I think everybody knows and maybe also recognized um, that AI is a massive growing technology. And of course, the latest interesting development was the DeepSeek, which simply allows us or gives us the idea that we can use AI. Sorry, I have to accept some more attendances. To use AI in more applications simply because the needed calculation power is not so high as it was. And the idea now is from today's webinar simply to show you um, the difference between, let's say, the standard machine vision approach and the AI approach, or the advantages of the AI approach. And this is done in a few slides. Of course, I will show you some examples which we made. Of course, it's our webinar, so which we made with our software for robot vision or standard vision, which allows us to make new and much easier solutions or much faster solutions, faster time to market approach. One of the major things, I think, in today's industries. So let's start. Normally I have a presentation stuff. It's not working. So I do it with the mouse. Let's go to the next. So what I want to talk today, of course, a short introduction about EVT, what we are doing. Maybe everybody knows it, so I will make it very short. And for all who doesn't know us, they get a glimpse how we do it. If someone is interested in the slides, we can share it after the webinar. So you get a mail and can download it from there. Then the next step is how EyeVision does this next step or enables you to do this next step. And the next, after this short overview about EyeVision, we simply have a look to different applications which are done with EyeVision, with AI and EyeVision, today's theme mainly. And so let's start about EVT. So right now we are 25 years old. Our core technology is software. That's what we can do and what we are doing. We integrated nearly all camera manufacturers which are known for 1D, 2D, 3D terminal hyperspectral images. So we have the option to allow our customers to use always the best camera technology which fits into the markets. Or for not for the into the markets, but for the application. Um, so it's not really it's not only limited to a certain number of camera manufacturers. Of course, during the last 25 years, we sold roughly over 58,000 licenses. So we have a nice basis of users, and we still develop the EyeVision from the beginning. We started with, as everybody, 1 or 2D machine vision. And of course, with the increasing of computational power and sensors, we added 3D and thermal and hyperspectral images. And of course, one of the most advantages in the last years was the AI, which brought us always a step to where we want to start at the beginning, the single button solution, uh, which AI starts to enable us to do this. So let's have a look to EVT. Our headquarter is, of course, in Germany. We have a subsidiary in China and Korea for the Asian market. And you see here over the world different black dots. These are related to our distributors and integrators. That means you have always normally an integrator in your time zone or maybe also close to you, so that it's very easy to get support. If you, of course, it's always possible to have direct connection to us. So simply feel free to contact us at any position if you need help or you have any questions. What is a major power of EyeVision? I would say, of course, one is the operating system. So we support all kind of hardware, which allows you always to use the best hardware for your task. That means if you want to run it on a computer, you can use any computer with Linux, Windows, or Mac OS. With Linux, we support also the ARM and MIPS platforms. That means, for example, you have a lot of smart cameras available where the EyeVision software runs. And if you want to use, or if you use a standard PC or a normal computer, you can use any of the cameras which we support. Roughly over 80 manufacturers, and most of the manufacturer have a full camera lineup from 1D, 2D, 3D thermal and hyperspectral, so that you can simply select the best fitting camera in price, in size, or whatever, or maybe the camera manufacturer you like. Of course, we support Industry 4.0 or Internet of Things. So we have all major protocols integrated, which allows you to communicate with your PLC or with your machine to a SCADA system or whatever. What we also support and where we support our customers is with accessories like light lens support. If you don't have the expertise, you can always call us. And also, if you need any embedded or PC system which fits to your application, maybe you need a small embedded system like, for example, a Raspberry Pi with a ARM processor or an NVIDIA board, or if you use a standard PC, EyeVision is always working on that. And of course, we support different I/O. Beside of the communication protocols, we also have direct PLC support, which enables you to communicate over a digital I/O. So this was a short overview about EyeVision and the supported hardware. I just mentioned it. We have because we come from the 2D area, we have a strong metrology package, which works on 2D and 3D images. We have a lot of 1D, 2D algorithms for code reading, object counting, and so on. We have a special instruction set for thermal imaging, which is a growing market beside of the 3D market. And the latest development in camera technology was the hyperspectral. We support all the current available hyperspectral cameras. And finally, we have integrated the deep learning into EyeVision and the robot vision. Also really flexible. So with robot vision, you have a choice of a number of ready installed robots. And with AI, which comes in the next slide, you have also some additional features. So AI, our approach is not to have a general AI. Sorry. Our approach is not to have a general AI. The idea is we have different pre-trained networks for the different industries. And of course, you have the option to train your network or to do transfer learning. That means if you have a product which fits to one of the pre-trained networks, for example, if you have any kind of screws, and the pre-trained network is not working with your screws, you simply can add your products to this network. The advantage of this is it's much faster in training. Let's say it's maybe something like it's much faster in training. Let's say it this way. So you don't have to start at scratch. And the other advantage is, of course, we have the transfer learning package inside of the EyeVision software. That means you can do all the training for the AI simply in the EyeVision software. You don't have to leave it. You can capture the images for your training with the software. Of course, you can if you start by scratch, you can generate a user-trained network. You can make a new one, then you need more time, let's say more powerful hardware. If you have, it depends on the time you have. If you have not so much time, you need a powerful hardware. If you have more time, you can do it with less powerful hardware. You have all the trainings inside of the EyeVision software. So what are the challenges in modern production? Of course, we have a massive increasing complexity of tasks in the manufacturing. And of course, we have faster variety. Therefore, you need, first of all, a flexible product. And this product should support all kind of sensors, of course, to get the best image for the evaluation. And finally, if the product should also enable you to solve things which you cannot do with standard algorithms. What do I mean with this? If we go back to the classic machine vision, which is part of the EyeVision software, here I have this classic solution here on the upper side. You see a gray image and you see a lot of measurement tasks. It's still in the EyeVision software. You can do it always, or you can mix it. But you see, it's a little bit more complex because you capture an image, you have to think about the object, then you have to measure the different tasks. And if all the measurements are okay, you have an okay image. For many tasks, which are anyway, all since machine vision is in the market, which are there, it was not possible to do it with the standard algorithms. Therefore, when AI came, there was the flexibility to train the parts and simply work on them. So if you use the classical algorithms, you wouldn't solve this kind of application. Here you see on a metal plate some fish, and with standard algorithms, you cannot separate it. It's a classical task, and each human would look to this image and would say, okay, would find the fishes, but the standard algorithms couldn't do it. AI can do it. You train the fishes, and it will find them on the plate. So this is the challenge which have to be solved because more and more the products are more difficult. It's maybe here I selected the fish. Of course, there are other tasks. For example, you have screws on a metal surface and you have to check, are all screws there? It's exactly the same. The fish is, first of all, the food industry is a nice industry, and second, it's a nice example for that. What I can recommend right now for everybody, you got a download link from the EyeVision software. That means you can download the software and you can run it on your computer. Depending on the computer, it's faster or not so fast. So I would simply show you, where is it? Blah, blah, blah. I started the EyeVision software to give you a glimpse to it. So if you have started the software, you will get, in this case, immediately not this solution, but you start here with the program editor. Of course, you start normally. So I show you how you start normally. You start here with the tool set, especially also for machine learning or AI. And you have also the robot vision tool set in the communication part, where the robots are predefined. And you simply drag and drop the tools to the, let's say, recipe, and then it works. We pre-arranged for you a lot of ready-made solutions. So if you have downloaded the software and we name it projects, you have a bunch of projects for 1, 2D, 3D, 2D thermal solutions, 3D area, point clouds, or of course we have the deep learning examples or AI examples, let's say this way. There you find, for example, the fish segmentation, but you see a lot of other examples like tan detection, coil spin detection, a lot of examples simply that you can see are how the software works or how the models are working. We have a lot of AI models to do from number plate reading, license plate reading, license plate from cars. A lot of different applications which you can see on your site by yourself. So what I show you today are simply some examples which we already solved with the software, and which you can have a look by yourself or operate on it. The project comes always with the images. So also this 2D example is in the, you will find it if you open the project in the 2D area example, then you will find here this gear tools inspection, for example. I open it for you. It's only that you have a feeling how the software is working. So if you open this project, you get immediately here the program which does the tier 2's inspection, and you can run it, and you see here, if I run it, or you can run it fully automatically, and then it works like it works like on your production line. So we have always a bunch of images available so that you can see how it works. And of course, if you have a camera, you are always ready to capture your own images with the camera. Uh, uh, in that case, you simply change from load image to capture image. And then if you have a connected camera, which is supported, you have the option to take your own images and use these ready-made projects, or you modify the ready-made projects for your task. Therefore, of course, we have our YouTube channel, which shows you, or our Academy, which shows you how to install all the stuff and how to select. I only want to show you here some small steps that you see that it's not really difficult. So here you have the option to select between, as I told you, we have 80 camera manufacturer. So you will find here, of course, any of the camera manufacturer which fits, which you might have. Or if you have a camera with which supports GanyCam, you can use our GanyCam implementation. Or if you have a Windows system, of course, this is GanyCam GigaVision, you're always able to use the integrated video stream from Windows. So you simply select, in that case, the direct show for Windows. If you have a Linux system, you can use video for Linux and capture your images. So you can test the complete software after you've downloaded it by yourself, even also either with the pre-stored images, or you simply select one of the cameras, or you use a USB camera connected to your PC or embedded system, and you can capture then the images from directly from the camera and operate on these. So this is mainly what I want to show you live here from the software today, because I think it takes, or it's much more valuable if you go by yourself through the software and have a look how it's working or not working. And of course, if you have a question, simply feel free to contact us. Either you call us, we can have a Zoom meeting, or you can send a message to our support team, which will help you to test or set up the system, that you can see how powerful the software is. So the software for machine builders, of course, why for machine builders? Most, of course, also for integrators. We have more than 80 cameras, as I just told you, and I showed you the list in the software. Here you see the application parameters, which I opened up before on the lower part. We just opened it in the EyeVision software, and of course we have the same list for the robot communication. So if you have a certain task, you can select one of the predefined robot interfaces, or of course the robot interface is based on a flexible description of the robot communication. You can add nearly every robot which is right now at the market, which has a standard communication format and interface. That means interface means you either RS-232, USB, gigabit Ethernet, or let's say Ethernet, and within these protocols, one of the communication parts. So you can set up any kind of interface to the robot, and of course you have also a very powerful, or two powerful, add-on languages in the EyeVision software, which allows you to do the communication or special communication protocols. One is a basic interpreter. The other one, we have the Python interpreter also in the EyeVision software, which allows you to do these specialized communication adaptation. but of course, you can use these two powerful programming tools also for some other work, but in most cases, you don't need it. And beside the easy integration of the robot, of course, we have the full integration of AI, which is really important. Not everybody want to be AI professional. Mostly you want to make a solution, and therefore you simply want to make your solution with the with whatever you have to do, and don't think about what kind of training, what kind of image augmentation, and so on. Of course, it means in the software is an automatic image augmentation tool, which allows you to generate additional images besides the images you capture from a camera or from wherever you have to do the training by yourself. So here, image processing as the eye of the production. Here we have a classical example for it, where AI and let's say classic machine vision works together. This here is a small robot vision task. The robot grabs some images here with a 3D camera and detects where the parts are. So this is a special gripper in this case. So he calculates with the EyeVision software how to grab it, and after the robot grabs it, you see here in the 2D section a 2D camera, which is also connected to the EyeVision software to do some additional inspections. So the robot, after it grabs the part from the conveyor, it holds the part in front of the camera, reads some codes and measures some stuff, and then puts the part to the processing. And all these tools are in the tool chain of the EyeVision software. So the recognition of the part can be done with AI, and the combination of AI and 3D. In this case, if you have these, for example, combined 3D camera, this means it delivers you a 2D image, a 2D color image, and a point cloud. We can use the 2D color image simply to recognize the part and the position of the part, and then in the point cloud, and then you can go to the point cloud and use the 3D part of the EyeVision software to detect exactly the position where to grip, to have a precise position information in 3D to move the robot at the right position and grab the part. And finally, if you have grabbed the part, you can, of course, either, if it's not needed to do additional inspection, to the processing of the part, or as in this example, we have the 2D camera and do some additional inspection. And this is simply combined together without additional need of tools or whatever. It's completely integrated. Another example for AI, so you can use anything what you can train. In this case, we use the fruits or of course some packages. The size doesn't matter in this case. You could use also bigger. We see later another application with some bigger or real world parts. But to give you the advantage in this case, we have the pre-trained network for the fruits, and of course the robot grabs the fruits based also here, in this case on dual sensor. So we get a color image and a point cloud. That means we can detect, we can recognize the part with the AI to see it. And wait, there's one additional attendee. So we can simply recognize the part with the AI and do the grab information based on the point cloud, which allows us to do all the path planning based on real 3D information, which makes it much easier to do path planning, sorting, and other things. The other thing is the classic small part of industrial solution for warehouses. So we made it for a show. Sorting any kind of boxes on pallets for, let's say, palletizing or depalletizing. Also here, the recognition of the part is done by an AI, and the grab situation is solved with the 3D part of the sensor, and the path planning and grabbing is also done in 3D, so that you have all the orientation values in the orientation values for the robot. So why it's not moving? So no, okay, the next one. Of course, here is a classical quality assurance task. You see on the lower level, the traditional solution is you do the inspections with the classical application. Here also with the classical OCR reading, and here with some measurements. Here you see the machine with the different cameras and everything. And on the upper part, you see here a surface inspection. So, of course, most of the tasks from the lower part could be done also today with an AI. So, or with today you would do some things with a mixed AI and classic evaluation. That means AI can tell you, okay, it's a good part. What AI cannot do is, of course, if you need exact measurements, AI can also say, yes, it looks good. But if you need a precise measurement, you need, let's say, the classical tool to measure something. It's similar to a human. You always can see, okay, this is the correct part I have in my hand, but you never can say, oh, this is 15 millimeters, 15.02. You can say, okay, it's roughly 15 millimeter as a human, and AI is exactly the same. AI can tell you, okay, this is the right battery, for example. But if the diameter of the battery is exactly, let's say, 8 millimeter, an AI cannot do it. It can say, okay, it's the right battery, it has the right print, but if the numbers are correct. So that one of the advantages in this case is to use the two options in one. That means you simply use the AI to recognize the part, see where the part is located, and if you need more, like for the example with the robot, for example, you need the diameter, the length, or whatever measurement you use for that, the classical measurement tool. But the speed, for example, for recognizing the part, where it's located, and so on, it's much faster to be done with an AI. And for the real values, of course, you use the standard application. The other thing is here on the top, we have here some surface problems, or you looking for on the surface for some, not problems, defects or whatever. This is it. You can do it with some classical algorithms, but it's always very sensitive. And with AI, you can do it easily, simply by training the good part, how a good surface looks like, and you can get anomalies in the surface. without training and adjusting all the tweaks and tweaks. So the speed um, from application to solution, time to market is much better with AI. Even the maintenance to be sure that it's working most of the time perfectly. Of course, you have also to adapt with AI systems from time to time, but much less. So this is a classical example of where AI image processing helps increase the time to market and also even to find defects, like especially cracks. Cracks is something which is really difficult to be solved with the classical machine vision solution. Another application, the full integration of vision systems with edge computing. That means you don't have to use always these high-end systems. You can use these specialized computing power computational platforms. So here's one example for this kind of inspection. You use a classical, of course. You need a camera. In this case, it's a triangulation sensor from any manufacturer. You have a list in our software which fits. So we can give you some support selecting the right, or let's say not the right, one of the sensors which fits to your needs. Mostly there are different manufacturers with similar value, with similar accuracy of the sensor. And so we can tell you, okay, maybe automation technology, LMI, Bangalore, or whatever fits you. You can see it in the list, and we can give you the idea if you need this accuracy, maybe that sensor or the sensors from these manufacturers would fit to your needs. And then the question is always where you want to calculate it or where you want to run it, even if it's AI. And the advantage is that you can use these accelerators, the edge computing systems. Of course, you can always use AI system based on a PC with, let's say, an NVIDIA board inside, which is currently the standard. But since DeepSeek, also since us, we support also Coral and Halo for the evaluation task. So if you have a production line, then it's not always necessary to have an NVIDIA product. You could also use one of these edge computing platforms. They have less power consumption, and of course, they are much smaller. They have a lot of advantages, and finally, you get exactly the same result with less hardware power for the solution. Of course, if you want to train or you have to train or retrain the models today, currently you need one of the powerful AI hardware tools. Right now we support the NVIDIA for the training, if it should be somewhat fast. So let's go one here. We see this classical pick and place or task. So we saw it before. We have the EyeVision software with all the robot vision, the AI, and this other task inside. And to make it much easier, we call it eye picket, the eye and the picket. So we have a bundle. If your task is any kind of palletizing, depalletizing, or bin picking, the iPicket package allows you to make these solutions very easy. So we have this is mostly a package with the EyeVision software with a fitting sensor and the robot. Of course, you can buy or use your robot you want to have. To make it easier, we have the package. The main interesting thing is we have the AI inside with the pre-trained networks, which allows you to make either makes the solution right away. If it's any kind of package with AI where you have a trained network, or you simply do an transfer learning. That means training some of your parts which fits into the same category to speed up the inspection or the solution. And of course, we have these pre-installed robot communication setups. So if you have one of the defined robots, you simply connect it and you can start right away. The combination of the AI tool for the recognition and the point cloud to find the right gripping point. In this case, that's why I have used this image. You see the boxes are not flat, they have any angle. So you get the angle out of the point cloud in what angle ever it is. And the grabbing is, this is mandatory to have a good grab point to have the right orientation for the gripper. If this is let's say, small demo tool gripper, or if this is a gripper from, let's say, Schunk or some of the other manufacturers, it doesn't matter. The important thing is that you get the information about the orientation of the part you want to grip, and of course to get it with a perfect accuracy to grip it from the table. And I think the real fast thing is you have this integrated training tool, which means, okay, the robot says, or you set up your system, you put the parts, or you have a pallet with the parts on it, and the system says, okay, I cannot do it. You simply can use the EyeVision software and the installed camera. You tell him, oh, look, this is the new part, and do the transfer training right away. And within mostly, it's not totally different. Within 5 minutes, if you have an NVIDIA graphics board inside, you are ready to go and can start solve your application. Here you see a robot which is sorting, depalletizing, because the cardboards are on the pallet. It's depalletizing the cardboards based on, in this, I know it, but you could use also any other. A photoneo sensor looks to the pallet, and the robot picks the right cardboard and moves it to this position to bring it to the rest of the production. So, and as you can see, in this case, it's a ABB robot. We don't care about the robot, also not about the size. In the last application, you have the small robot. Here we have a bigger one with bigger parts. The size of the parts depends only the right camera or the right sensor with the right field of view. If you have small parts, you use a sensor with a small field of view. You have the bigger ones, you use the bigger ones. To make your solution. I think one of the major tasks is of course, if you have a heavy part, you need a bigger robot. If you have a not so heavy one, you can use a smaller one. I think these are the main. This is evident that you cannot use a small robot and grip a 10 kilo whatever part. You need the fitting robot. And for the right part, you need the right sensor with the right size. So another application beside the robot vision, but also in this case, robot vision is sometimes used depending on the task. This is seal and or adhesive or seal bed inspection. Here we have a classical part. You can also you have this project to see how the seal inspection works. We have different seal parts where we either use the classical tool to determine the seal site or defects in seals. These are two different seals. This is a seal in a housing, which is then processed to ready-made part. And here we have seals where you don't want to have some defects in it. And in both cases, so in this case, in the upper case, you could use the classical inspection to find out maybe smaller damaged seal parts, or you use an AI. In the lower part, the damage, the inspection is more sophisticated, and therefore you use the anomaly detection. So you train it a good part, and it searches for the anomaly. And of course, you do it in real time. This machine runs really fast. And the really interesting thing is, of course, the parts vary from manufacturer or from brand to brand. So, of course, the AI mostly recognizes the parts immediately without training, but some of them are so different that you simply have to retrain. You have to retrain some of these parts if they come. The same. So normally it's exactly the same approach. If you have an adhesive or an adhesive inspection, means glue or seal, or if you have a weld inspection, of course, weld has some additional defects. Therefore, we have a pre-trained network for weld inspection, which knows all the different things like pores, voids, and this kind of things, which are difficult in this case to do it with standard algorithms. Of course, if you have a 3D version of a weld, you could do the inspection in 3D. But also in 3D, it's difficult to analyze how for example, a pore or a void. You always have to recognize, okay, the depths, the lengths, the depths, and the lengths, depths, and widths. And then you can define, okay, this is a pore or these are too many. If you use AI in this case, or if you use the pre-trained network for that, it knows, okay, if the weld has this size, if you have one pore or two with this shape, then it's okay or not okay. It's much faster than to define the pores based on dimensional numbers. This enables you to make these inspections much faster. And in this case, the weld inspection is done with a triangulation sensor, but of course you could also use a shape-by-shade sensor or any other high-resolution 3D sensor, which enables you to see the weld part, so that you can do the additional inspection. The interesting thing is here, I just wrote it. We trained this weld inspection based on in a combination of with X-ray images, which allows us, which is difficult if you have only a 3D image, which allows in many cases the AI to say, okay, I see this pore and I know this pore looks like that. This is the description of the human, that in the if you look it in the X-ray, you have more problems under the weld. So this is a really interesting solution which combines the sensors and these sensors, and you don't need an X-ray sensor in all cases. So we are nearly at the end of today's presentation. Maybe a short summary. First of all, I highly recommend you that you download the software and test it by yourself. You can use everything from AI, 3D, and even image capturing. So if you recapitulate what I told you today, you can have a look to the different projects and test, see in the different projects how it works. If it's a 3D application, an AI application, of course, even a robot vision application, if you have a fitting robot around, you simply can do that. One of the big advantages is the pick and place applications, especially what machine vision says is bin picking. You have any kind of stuff in a bin, and you have to pick it out of the bin. Simply the basic recognition is much easier if you use an AI for the recognition in the bin, and then the 3D information to find where to pick what out of the bin. Of course, glue and seal inspection is much easier to install, and based on the predefined network, you get a real good idea when is a glue or seal good, or when is the weld good, especially all these small defects and definition of the defects in welds. You can handle it with a classical application, but then you have to say, okay, if the weld has this width and the pore has this width and length and depth, and if there are more than one, then it's a defect. So the AI simply is trained find if there are pores. They have and they look like this, and there is more than one. He says, okay, this is a defect, without defining all these small details. So that's why we say AI is a real advantage in many applications, palletizing, depalletizing, especially if you have a pallet with different parts on the pallet, which are difficult also to recognize, maybe because all are card boxes, but with different size, and they are very close together. It's difficult to recognize the position, the orientation, or where the boxes are. The AI will tell you, oh, look, I see the boxes, and then you can, with the information where the box is, you can simply use the 3D information to grab it at the right position with the right gripper. So it's a real advantage for machine vision solutions. And of course, for us, why EyeVision is a game changer, because we added all this information, all these tools in one application. So you don't have to change between applications. You have an easy access to all the image capturing tools, the communication tools to the rest of the world, IoT, or to SCADA systems. And with all these together, it's very fast to make a solution, and not make a solution, make it fast, time to market. Here for the end, some other examples. We have a lot, and of course, if you download the examples, you find them here. This is meat cut based on the shape, so that you have always the same volume, or here a bottle inspection, or here a thermal inspection. In this case, if the thermal seal is perfect, and many more, simply to give you an idea about the versatility of the EyeVision software and how to make solutions with it. So now, if you have some questions, I'm here. You can simply ask me, or feel free to send me a mail, call me by phone, um, and I will answer you the questions. Or if you want to test the EyeVision software, uh, you have questions, simply let us know. We will help you to see how you can do your task with the EyeVision software. Um, with this are the closing words from me. So I'm now here for your questions, or if there are no questions, um, I would be happy to hear from you. Yes. I see there are no questions. That means I would say thank you very much that you attended today. And I hope to hear from you. And with this, I close the today's session and say goodbye.